Hello to viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about is nuclear energy is going to play any role in our future? And I'm talking about fission, not fusion. So let's dive right into it. Now, what was the dream of fission? Well, a sustainable source of energy. Now, be very mindful, it's not classified as renewable because Earth is not making any, more new elements for us to split apart. So there is a finite source. However, the amount of material available is so huge and the amount of consumption is so low that it's like, trying to drink ocean dry. Not going to happen. So fundamentally, it's a sustainable source of energy, and it has no air pollution, which is the big issue with the coal power plant system. And it does not even do river blocking, because you have to understand, while we thought in early days that hydropower is the awesome thing, reality is the hydropower causes so much devastation to ecosystem, ecology, everything associated to it. So it's a very disastrous solution. Like we did that in early 1950s and 80s, and it's like, oh, it destroys everything in its path. So now we realize that this is not a good thing. Like doing twink and just this is Three Gorges Dam and just blocking it, not a good thing. And not to mention, like, it also dries up the river and causes flooding. You will think it would do opposite, it does opposite. So reality is it's a very awesome thing, and it's 24/7, which is very desirable, and it is not affected by weather. Yes, you can put wind farms in many places where they are working 24/7, but here still they are still dependent on weather, meaning their output could change. There could be like, hey, 60 watts, awesome, 60 megawatts, awesome, and sometimes it's like 600 megawatts. It's like, what the hell happened? Again, wind speed changed. So that's a very serious scenario. It's not affected by the weather, meaning you get to control it, and it can single-handedly feed 100% of the need. That's the biggest GG aspect of it, meaning whenever you are talking about any renewable, nobody's going to say to you, it's like, this renewable, done, go home. Everybody's like, you have to have solar, you have to have wind, you have to have geothermal, you have to have wave, you have to have tidal, you have to have biomass, you have to have biogas, all that combined, then you will take care 100% of it. That's true. But here's the deal. This puppy is like, I got this, fam. I got this. Enough. Directly enough. I got this. Don't worry too much about it. So that's the dream of the nuclear era. So what's the problem behind it? Well, the problem is it's too goddamn complex. Meaning, let's say normal humans are here. You need to be here in order to understand it. It's idiotically complex to illustrate it mathematically. What kind of complexity we are talking about? You have to understand periodic table. Most people understand that. That's a, oh, periodic table, I understand. Yes, this table is something that you have to understand in order to go to nuclear industry, meaning table of nuclides. Just Google that, how. And yes, these are not dots, these are all elements. And that's why, like, isotopes is something that you have to understand, because all isotopes are not stable. Things that are here, they are stable. Things that are here are YOLO, meaning some of them will be appear there only for 5 minutes, some of them will be there for 3 days, some of them, you have to study all of that. Because if you have watched the Chernobyl TV show, you would have talked about, like, xenon. It just changes. It's like, if you study this table, oh, that's why xenon is changing, or that's how it's changing. So when they say xenon will burn away, it does not mean burning away. It simply means it is absorbing neutron to stabilize itself. So you have to know all those things. It's not a normal science. Like, it has an illusion because we study in class, class 8 and 10. So we kind of get an illusion. Oh, it's this thing. It's no, sir. No, it's like you have to study nuclear physics, and even then only few people can truly understand this. Most people can just, like, do the tic-tac-toe, but truly understand it, very few people can do that. And nuclear fission does not tolerate mistake, meaning there is no scenario where it goes like, oops, I can dial it back. There is no oops, meaning you make a mistake, it goes boom. And I mean, like, there is not even a single dollar. Like, think of it this way. Let's say you are talking about GG amount of solar farm, and you messed up something in the substation. What will happen? You will fry some inverters, you will fry the substation, you can repair it. You messed up something in the solar panel, you fry the solar panel, you replace the solar panel. Dam does give you some warning before it cracks and comes, but it also gives you some time. Coal power plant, super easy. It will give you enough warning. It's like, bro, come on, fix this thing before it goes too bad. This puppy is like, no, just like, oops, boom. Like, there is no tolerance of mistake, and humans make mistake. For example, Fukushima plant was like very simple thing. It's like, hey, it's a plant, and we have a situation when we're supposed to have backup generators, and some idiot decided to put all the backup generators in the background. It's like basement, basically. You're not supposed to do that. You're supposed to have your generators spread apart, and not to mention on multiple levels. So one single scenario should not destroy all of them, and they failed to do that. Boom. That's the whole point. Mistake is not tolerated. 3 Mile Island, there was a flap that was, yelling a light that is like, bro, the flap, this valve is not working, please redirect. If they would have just noticed that, 3 Mile Island would not have happened. It does not tolerate mistake, meaning there is no, oh, I got this, oh, I'll take care of this. No. It's like, you made mistake, it goes boom. And one of the most common illusion that I've seen about nuclear technology, specifically with a new modern CGI world that we are living in, where it's like small modular reactors and blah, 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 and all that. It's like they show that reactor can be turned off. That's not true. Nuclear reactor has no off switch. All it has is throttle. You can throttle it up or you can throttle it down. You cannot turn it off. So when it is like, we're going to have control rods, all the control rods going to go in. Here's the deal. All that does is throttle the output from full output. Let's say it's 3 gigawatts of full output, like one reactor. And again, 3 gigawatt does not mean 3 gigawatt electrical power, 3 gigawatts of thermal power. That's not that much. Okay, here's the, you throttle it down, you're like, okay, it goes to 0. No, it stays at 300. Now, what the hell? Because you did nuclear fission here, it has enough of these things decaying there that is creating heat. Radioactivity is not magic, it's heat. Inherently there is heat there. What does that mean? That simply means when you scramble, let's say something bad happened, earthquake happened, you scram the reactor. Okay, everybody's like, GG, we saved the reactor. Yes, nothing changed to the reactor's point of view. Reactor still needs cooling, and be mindful, it's cooling hundreds of megawatt of heat, because that heat is being generated. It's not like, oh, you have reduced the fuel. It's still burning. It has more than enough to go on for days. To give you a context, these are pools that require cooling water for spent fuel for 2 years upwards of. Let that sink in. For fuel that you have spent, used from the reactor, you pull it out, you bury them in this pool, and you keep circulating water over it for 2 years before you can ship them. That's the power of radioactivity. And you are thinking, oh, we're gonna just put control rods since the reactor is off. No, reactor just went from GG amounts of power to low power. And at that point in time, you have to keep cooling it. And that's why Fukushima went boom. It's like the moment they try to scram system, earthquake, shutdown system. Yes, deal. Tsunami happened and they did not have backup plants, as in like backup generators. There was no water running through the cores and boom. That's the whole thing. There is no shutdown in a nuclear reactor. Now, best estimate says minimum 24 hours of continuous cooling water. And be mindful, these water cannot be just like water. It has to be high pressure. Otherwise, the reactor will boil it off and you will not be able to put it. So you need high pressure water injection system. If you do not do that, your reactor goes into meltdown. Meltdown simply meaning the fuel channel melts, and generally it has enough radioactivity, enough oomph into it that it can punch through almost anything. You just hope it gets diluted enough by enough concrete, enough steel, enough stuff that it becomes diluted enough, then it's just hot. But if it's not diluted, let's say mass of it just goes through, it will punch through anything. That the elephant foot in Chernobyl, that's the thing. The reactor core pushing down. So that's the whole point. There is no off in nuclear reactor. So all these images are showing, we're just going to turn it off. It's like, dude, after turning it off, you have to keep it circulating water. And where the heck you're going to get the power? That you are seeing recently, people talking in, Ukraine war. It's like, how the heck you going to keep the power plant? It needs electrical power so it can keep itself safe. Turning it off, then you have to keep basically, feeding it cooling water for around 24 hours to 1 week to 2 years. That's the problem with nuclear system. It does not tolerate mistake, and there is no off state. Off state simply means low output, not zero. And not much cool. You have to imagine things this, like somebody is trying to tell you, hey, can you keep cool down a 300 megawatt heater? Try to think about that. Like 300 megawatt, you have to keep cooling down continuously while you do not make any power. That's the whole issue. And to give you a context, like what kind of complexities we are talking about, till this day that nobody has agreed upon is like what exactly happened in Chernobyl, as in like what exactly the series of events, like which nuclear jumped the first gun, like nobody knows. And in terms of Fukushima, which is a recent event, I have provided a video there, which was like 2020, and that was the years of investigation. They are like, I think now we understand what happened. Nobody understands anything about nuclear series. It's almost magic for us. If you just know how to, basically we are like early caveman humans, we figured out fire. We did not understand like, things are oxidizing. Same thing here. It's like we understand the roughly how it works, but good luck trying to make it secure and safe. And not with, like, it really pisses me off. It's like we're gonna have control rod. It's like, that's half of the problem. After that, what the hell you gonna do? How the heck you gonna have enough power for the cooling? And you need pressurized cooling. You cannot just like, oh, hose the water. It needs pressure and hundreds of psi of pressure and boatload of water and some way to dump that water into some heat exchanger so it does not boil off, because if it boils off, you run out of water. So that's what's the problem behind, core problem of nuclear reactors. Then we come to the reality of it. Here's, I have specified time and time again, there is only 3 layers to things: physics, engineering, economics, meaning physics. Does physics allow you to do it? Yes. Engineering, we have some competency, we can make it. And then we come to economics. Is it financially viable? The answer is no, flat out no, because here's the deal. Even the most optimistic case study that you can take, in even the most ardent nuclear fan you can talk to, and I'm talking actually engineers, scientists and all that, even their estimate is hyper expensive, meaning how much money that you have to put down in order to make a nuclear power plant for, let's say, given capacity, 1 gigawatt capacity, 5 gigawatt capacity, 12 gigawatt capacity, like there is an X amount of money into that. That is very high compared to all other systems. It's much, much higher. Now, here's the problem with that. Even though you might say, oh, it will make a return on investment and keep working, those things are assumption. And on top of that, if you can't get the capital itself, how the heck can you go build it? It's like, if I go to, let's say, Indian government, it's like, I want to build a solar farm. They're like, shut up and take my money and just build it. Just go away, shoo. If it go to them with a nuclear plant, it's like, yeah, we don't have enough money. Nobody does. It's idiotically expensive. And it takes decades on return on investment. That removes almost all private companies where they are like, yeah, no, we build this, we hope that we stay there, and we hope after 15, 20 years starts to pay up the money. That takes very long. And because of inflation, it also getting worse, meaning all the design, the optimistic calculations, they are from reactors that have been built years ago, as in like early 1990s. Modern reactors does not exist because no country is like, yeah, we're going to build a reactor in 2025 and then it's going to be, functioning in 2050, and then we're going to be like, okay, making our money back. Nobody is doing that. So all the designs that you're seeing and all the plants that are under construction, they have been like, stuck in hell of development hell, and now they are being built. So that's why all the new reactor designs have been gone. It's like nobody wants to take that capital cost. It's like, who's gonna, it's like, spend this ludicrously large amount of money, hope nothing goes wrong for like, 20, 30 years, then you would have made enough your money back, and hope inflation has not made it worse. It's like, it's hope on top of hope on top of hope. That's why financially it does not make sense. Yes, in back in the old days, it made sense, but now it does not. And then we come to the crux of the matter. The crux of the matter is that safety adds more expenses. For example, France built a lot of reactors. Every time some nuclear disaster happens, every other nuclear operator has to upgrade their designs. They have to train their staff, they have to do things. Yes, deal. That means the running cost goes up. Consequence, their return on investment pushes back. So every company that is running a nuclear reactors is like, God damn it, we have these reactors, and keep increasing the price. Just keep increasing the prices. Like, again, you want safety. Can you make a reactor that is safe? Absolutely. Is it viable? No. And this dialogue is the most accurate dialogue ever in Chernobyl. It's cheaper. Like, they were not stupid. They were like, dude, nobody would buy expensive power. Here's the people complain about Germany's power bill. Imagine like if somebody's like, France comes along, is like making more nuclear power plants, more and all that jazz. Again, modern time. Not all days that you are successfully able to upgrade. I'm talking brand new. Electricity cost would be 3x what it was. People were like, dude, what the hell? And that's why no country is investing into this. It's like, yeah, the cost of electricity now would be so high that people will not buy it. So that's the reality of it. And everybody wants cheap power. This is inherently against that, because if you make it cheaper, you make it unsafe. And that's about the capital cost. I'm talking about just the oomph that will go into starting this puppy. Then we come to other aspect. Regular and proper staff training. Chernobyl could have been easily stopped. Fukushima could have been easily stopped. 3 Mile Island could have been easily stopped if you had regular and proper staff training. Okay. Now, why didn't they do that? It cost increase, meaning your running cost, meaning how much money that you are just spending on running the staff, that will go up exponentially, because every year the cost will go up because of inflation. So fundamentally that's not doable, like not viable. Like, you can do retraining every 5 years, but good luck with that. You have to be very rich in order to do that. So fundamentally it's not viable from a financial point of view. It just keep increasing. That's why all the modern cost of nuclear plants is like, it just does not make sense. It flat out does not make sense. It will keep going up in the air. And then again, this thing happened. Like, this is a real thing. It actually happened. Unit 1, Unit 3 went boom. And then you have to understand another aspect. Once you have done all that and you still find out, you know what, I'll still make profit, but it will take just longer. The ROI goes like, instead of 10 years, ROI becomes 20 years. And let's say you are a government, you have the luxury of like time. Let's say you still put through. Here's another aspect that will make even the most hardened supporter frustrated, is that nuclear spent fuel requires storage. Now here's the deal. People are like, oh, we can store it. Here's the deal. That's not the problem. Problem is you have to pay someone to store it. For example, if you have a coal power plant, the fly ash is valuable, meaning you can sell it to cement plants and they will like, shut up and take my money and give me this fly ash. We'll put that into our cement. It actually makes cement better. Let that sink in. So that's a product. This is not a product, meaning every person, every contractor, every individual that is there, you have to pay them. People like, we're going to do this deep mining. Since when did mine become cheap? Like, let that sink in. Somebody saying, oh, we're going to do this deep mine, and we're going to bury everything. Awesome. Here's the deal. Since when did mining become cheap enough that you can just do it? And since when did concrete become that cheaper? He was like, oh, I'm going to drill this, I'm going to do that, and the people needed for this, the employee cost, all that. It's like, and that's a running cost. You have to keep doing it again and again and again and again. You have to do it. And who will pay for that? At the end of the day, who will pay for that? That's why it always fails at economics level. And that's why, inherently speaking, that's why nobody gives a damn about safety. Unless something bad happens to them, nobody gives a damn about it. It's like, how every Russians were like, we want, Russia forever. And it's like the draft happened. It's like, what the hell? What the hell happened? So same thing. It's like everybody wants to do it. It's just the moment the bill comes in. It's like the bill comes to you. At that point, you understand this man is cheaper. So that's the cost aspect of it. Not only the building a reactor that is truly safe, truly high quality, truly robust would be super expensive, and not to mention good luck trying to sell its electricity, as in like megawatt per hour would be so goddamn high. It's like it will be very difficult to sell. And then proper staff and training, all of that over year and again, over and over, that will keep increasing cost. And then the waste also will require more and more expensive system. And inflation will make this equation lol. That's the cost aspect of it. Then we come to the war aspect. This is the final aspect. Even if you can justify the cost, this is the aspect you cannot justify, simply because nuclear proliferation is a big issue for everyone. Again, it's one of those things that if you are not nuclear power yourself, you will not understand. It's like, hey, why do they need nuclear power? It's like, dude, because you have it. That's why they need it. It's like, if nobody wants other country to have it, but themselves. For example, Indians we want nuclear power, not Pakistan. Pakistan is like, we want nuclear power, not the India. Bhutan wants like a nuclear power, not the West Bengal. West Bengal is like, we want it, but not Bhutan. Same thing. It's human nature inherently. We have 200 countries, and every Tom, Dick, and Harry wants nuclear hardware, which is just dangerous. And again, out of spite, out of rage, out of fear, nobody wants this. And we have to understand, human nature is directly against this. So fundamentally, and again, look at what Putin did. Putin literally proved to the world that you have to have nuclear booms. Because again, Ukraine gave up their nuclear warheads. If they have not done that, they're like, bro, what's up? Boom, bro. So fundamentally, human nature is against nuclear proliferation. So fundamentally, now you may like, oh, nuclear reactor is not nuclear warhead. That is absolutely true. But here's the physics is exactly the same. Like the engineers, trained engineers, technicians, they know the same physics, they study the same thing. And if they have actual real world experience in managing the fuel, managing the spent fuel, managing the cooling ponds, everything, like if they study those things properly, do their job properly, over a few years, they will figure out how to make low grade nuclear boom devices. Now be mindful, I'm clarifying two other core things. Even a basic nuclear boom device is very powerful, as in like Hiroshima and Nagasaki, they are powerful enough. And be mindful, compared to modern warheads, those are toy warheads. And those modern warheads is thermonuclear. That is a different technology. Let that be very clear. If you know nuclear reactor and properly know it, you can make a basic nuke, but you cannot make a thermonuclear system. That's very complex. That is absolutely true. However, you can still make a basic nuke. Let that sink in. You can still make a basic nuke. Now, USA had a plan. They knew for a fact that everybody wants nuclear energy. It's cheap, it's again, the dream back in the days were true. But once they actually started to research it properly, calmly think down, it's like, if anybody has nuclear power plant and they are working on it, like truly studying it, they will figure out how to weaponize it. Like you cannot stop it inherently, because this part is the expensive part. And the moment you have a reactor, the moment you know how to operate a reactor, this part is building. So it will not happen on year 1, but year 5, you will know how to do it. So that was the reason. Now, those things are human issues. Remove those aspects. Then we come to the war, the moment, the passion aspect of it. It's a perfect target at war, and you cannot repair it. For example, Russia booms a substation. Ukraine is like, okay, we're going to send firemen, we're going to send electricians, we're going to send our best people, and they're going to get it back up running. 8 hours downtime, they get it up and running. Awesome. This is happening to a nuclear reactor. And again, Russia knows this for a fact that nobody is going to counter-attack this, so they can have the best place to attack things. And what if something bad happens? What if the place where they're actually storing nuclear, nuclear reactor is here, and they're storing ammunition here, and let's say some ammunition just out of fault goes boom. What the hell are you going to do at that point in time? What are you going to do? You can't send people there, because if there is enough radiation leak, which it would be there, they're going to be dead in a few days. So what the hell are you going to do? Like this, basically nuclear power plants that France is so proud of at this point in time, if there is a war against Russia, all Russia has to do is like poof their nuclear power plants. And like again, they will be like so trapped, so stuck. It's like they won't be able to do anything. Like they will be paralyzed by their own power plants. You can't just send people there. Like again, this happened. Like substation went down. They sent people. They got it under control. Awesome. GG. Again, expensive, loss of money. Nuclear, unsolvable. That becomes unsolvable, and that's why you will talk about hear about this is happening right now. Is that Ukraine literally have to make sure that their power into a nuclear power plant. Why? Because nuclear reactor does not shut down. Even if they shut it down, they have to keep running the cooling power ponds, heat exchangers, so the spent fuel does not go boom the reactors, or they have to contain it somewhere where they're like, dude, it has to melt through. Let it just. It will be unsafe, but maybe they will have to do that. That's the whole point. War does not tolerate nuclear reactors. It's like the worst thing at a war, because all they have to do is like, pook. The boom part will happen from this. So that's the war perspective, and that's the truth. We are seeing the consequence of that right now in Russia-Ukraine war. So I have seen many people, many videos, many people talking about nuclear. Oh, it's only if humans were this. Oh, that was human error. Here's the deal. We are only human. I'm not some alien. You are not some alien. So stop talking like, oh, there was human mistake. Of course it was human mistake. Every plane accident is a human mistake. That's why we would put 2 people on there. Every mistake is a human mistake, because humans are the only one doing things. So that will always be the case. You design things that can work around it. You design things that can adapt to it. Basically, you cannot bitch about it. Let's be realistic. Unless you are a child, you cannot bitch about it. You have to be, be like, okay, that's the human nature. How can I adapt to it? How can I strengthen against it? That's the whole point. Like, we have to be better. We have to learn more. It's like, no, I do not want to figure out. It's like the whole nuclear table in order to like, okay, I genuinely hope the person working in nuclear reactor is actually understanding the entirety of nuclear table. Otherwise, a button he presses, boom. Or like a dictator goes like, hey, they have nuclear power plant. Wouldn't it be nice something happens to it? I don't want that. I don't want that. Like, that's human nature. I want to understand. Like, USA literally were building a plant where they're going to build small reactors, and they're going to give it there and just going to train operators to operate it. Have electricity. Awesome. Problem was, then they realized, like, if you know how to operate a reactor, you inherently are a few years away from knowing how to make boom devices. So again, a boom devices, not thermonuclear boom devices, but still a boom device. So they're like, cancel that project. And cost matters for all of us. Everybody's like, what if we have a reactor that is super awesome, super robust, and super amazing and all that, with super trained staff? Instead of 3 shift per day, we have 4 shifts, so everybody is well rested, everybody is awesome. Yeah, pay for it. At that point in time, it's like, yeah, I don't want to pay. It's like, every Russians is like, yeah, awesome, Putin, awesome. The moment is like, I have to go to die. It's like, no. It's the same thing. Everybody wants cheap electricity. It inherently does not allow that. Now let's compare it to some options. Solar, wind, geothermal, tidal, biofuel. If you have all of these, yes, it will provide 100% of power. And yes, it does all of the technology that I'm talking. They are oops proof, meaning you will not have minor issues. You will have like this, but you will not have this. Like, and that's why I'm not talking about hydropower. This happens in hydropower failure. If a dam fails, it's disaster. So all these technology that I'm talking, they're oops proof, meaning something bad happens, yeah, it will hurt, yes, it will affect you, but it will not be like our next future mini series. So that's why they are all oops proof, and they are all war resistant, meaning you can endure it, you can survive it. That's why it's like I generally get frustrated when people like, oh, it's like, if they had a human, proper human. It's like, yeah, that's the same thing. That's why computers are replacing so many functions in aircraft. They know for a fact that people make mistakes. That's why they have 2 of them, and then they have a computer, and then they have a ground control that's gonna keep like, bro, did you check this part? Bro, did you check this part? Are you sure? That's the whole point of it. We make mistake, you design around it. It's like human natures are like this, you are a designer around it. Like, for example, you will not have a captain in an aircraft wake up for an 18-hour flight. It's like, bro, go to sleep. We know for a fact that you're going to make a mistake. Go to freaking sleep. And of course, tell them that you're going to sleep. Your co-pilot will take over. And then when you wake up, you will fly the plane, co-pilot will go to sleep. We learned this the hard way, that you have to sleep. So let that sink in. We are only human. You have to design around it. Nuclear does not fit this paradigm, so to say. Solar, wind, geothermal, tidal, biofuel, they do. So this was my presentation on can we expect nuclear in the future. Hopefully this would have clarified why I'm so anti-nuclear. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.